Good evening, everybody. Once again, my name is Ian Latimer, Project Manager on NYSERDA's Clean Energy Siting team, and it is my distinct pleasure to welcome all of you to the fourth event in our ongoing webinar series entitled Battery Energy Storage Systems, Key Considerations for Local Governments. Tonight, webinar number 4 will be focusing on decommissioning and end-of-life consideration for battery energy storage systems. As all of you know, or are soon to know, energy storage is playing an exciting and growing role in New York's clean energy landscape. And so it's great to have you all joining us this evening to learn more about such a key facet of this important technology. Next slide, please. And before we kick it off too much tonight, we're going to go ahead and go over some housekeeping procedures for tonight's webinar. All attendees have been placed in mute. You've been muted, so you'll see that there is that button on the right indicating that you've been muted. That said, we welcome participation, and we would love for you to submit questions and comments throughout the webinar at any time using the Q&A feature, which you can find in WebEx over on the right. Looks like that. And so please, as we're going through the slides tonight, if you have a question pertaining to information on a certain slide, you'll note that there are slide numbers on the bottom right-hand side of each slide. And please feel free to just note which slide you have a question about so that we can better answer it come Q&A at the end of the presentation. The chat feature, however, is disabled, so the Q&A feature will be your best bet for getting through to our team. Today's materials, along with the recording of the webinar, will be made available on our website at www.nyserda.ny.gov/storage guidebook. Also at that location, you can access recordings and the materials from the previous webinars in this series. All of those will be made available there. If any technical problems do arise, if you have any trouble connecting or if you have any trouble hearing the presenters, please contact my colleague Sal. You can reach him using the email on screen. It's sal.graven@nyserda.ny.gov, or just let us know in the Q&A feature once again. And next slide, please. I just want to call attention to the one remaining webinar in our series, which will be taking place a couple weeks from today on Wednesday, June 30th. And that session will focus on taxation and assessments for battery energy storage systems. We're really pleased to welcome our colleagues over at Hodgson Russ LLP, who will be joining us to talk about taxation and assessments for storage. And again, you can access all of the recordings and materials from the webinars in this series on our website at nyserda.ny.gov/storage guidebook under the Trainings for Local Governments header. And next slide, please. Just to go over the agenda for tonight's session. So we'll begin with a recap of energy storage in New York State, including briefly touching on all of the material that we've covered in the series up until this point. From there, we'll briefly step into an introduction to battery energy storage system decommissioning. What does that mean? What are the questions we should be thinking about? From there, we're very pleased to welcome the first of our two outside guest speakers for tonight. From DNV, we'll be talking about decommissioning energy storage systems. Following up, we'll have a representative from Lifecycle who will cover lithium-ion battery recycling. And then finally, we'll bring it all together for a Q&A at the end using any of the questions that you guys submit throughout the webinar tonight. Next slide, please. I won't take too long here, just a brief introduction. I mentioned we've got two outstanding guest speakers who are joining us this evening. The first is Daniel Pardo, a senior project manager at DNV. And then later on, we'll be joined by Kunal Falfer from Lifecycle. He's the chief commercial officer at Lifecycle. I'll go ahead and introduce them a bit more when we're closer to their portions of the presentation. But for now, we'll keep going here. Next slide, please. And we'll begin by, again, recapping what we've covered in this series up to date. So energy storage in New York State. Next slide, please. And it's hard to talk about energy storage without first talking about the Climate Leadership and Community Protection Act, also known as the Climate Act, which was signed into law in 2019 and codified some of the main electricity sector and technology-specific goals that are undergirding New York State's clean energy rollout. So first off, on the left, we'll draw your attention to some of the electricity sector-wide goals, which primarily are focusing on hitting 70% renewable energy by 2030 and achieving a 100% emissions-free electric grid by 2040. As a way of supporting those goals, we have some technology-specific targets that we're looking to hit as well. First off, we're looking to procure 6,000 megawatts or 6 gigawatts of distributed solar by 2025. Along with 9,000 megawatts or 9 gigawatts of offshore wind by 2035. And then for tonight's session, we're going to focus largely on the goals of hitting 1,500 megawatts of energy storage by 2025 and 3,000 megawatts by 2030. Now, the Climate Act also contains some pretty ambitious greenhouse gas reduction goals, including getting to 85% reduction by 2050. But largely, we'll be talking about the energy storage piece tonight. And you can see at the bottom there, there's a graph indicating the resource mix that's been used to date in New York State up until 2017. And this comes from a NYSERDA document called Patterns and Trends, the New York State Energy Profile. Next slide, please. So a brief introduction to energy storage systems from the ground up. Energy storage systems are storing energy for conversion to electrical energy. And the most common type that we're going to be seeing rolled out in New York State is going to be batteries, as they are the most common and flexible energy storage system in terms of deployment. Now, within batteries specifically, we're going to be seeing a lot of lithium-ion battery chemistries, which are the prevailing chemistries based on energy density, price, and a number of other factors. Now, when we think about energy storage systems, they look a bit different than the lithium-ion batteries that we are used to in our phones and in our laptops. The cells are similar, and that's sort of the building block of the energy storage system. You start with the cell level, and then when you wire those cells together, you have what's known as a module. And when you wire those modules together, you get what's known as a rack. And those form sort of the building blocks of these energy storage systems. In addition to those components, you also have what's known as the battery management system, which basically acts as the brain, the eyes, the ears of your energy storage system. And it can tell you, how you make sure that everything is operating under normal parameters. And if something were to happen, that's going to be the thing that triggers the people who are monitoring the system to know that they need to take action. In addition to that, there's also a number of other monitoring, safety, and balance of system equipment, which goes into an energy storage system. Now, the three photos on the right give you sort of an idea of the scale that we're seeing energy storage systems deployed at. On the top left, you'll see a residential example of energy storage, which is a Tesla Powerwall, which is in the kilowatt hour range in terms of the storage capacity. Below that photo, there's an example of a commercial energy storage system unit, which is installed at a commercial park in Westchester County. And that one's going to range in the kilowatt hour to megawatt hour range, generally speaking, for commercial storage. And finally, you'll see at the right, we have an example of a utility scale storage system. This is a 20 megawatt system installed in the capital region. And this one will range generally from a megawatt hour up to a gigawatt hour threshold when we talk about utility scale systems. Next slide, please. Now, as far as use cases for energy storage, we're looking at battery energy storage systems to serve a variety of important roles for the grid, including these more common uses. Number one, from a utility perspective, they can help defer costly upgrades to transmission and distribution infrastructure, which can be one of the most cost-prohibitive parts of running the electric grid. We're also looking at energy storage facilities as a way of providing key grid services, such as modulating voltage throughout the grid, making sure that supply and demand are exactly equal, given the sensitive nature of the electric grid. One of the primary uses of energy storage, and one that we're all probably pretty familiar with, is how energy storage can support the integration of intermittent renewable energy generating systems, such as solar and wind, i.e., how are you able to use energy generated by your solar and wind farm when the sun is not shining or when the wind is not blowing? And that's where energy storage comes into the mix. But in addition to that, energy storage is also being looked at as a way of alleviating congestion in the grid, reducing brownouts and blackouts, and replacing polluting peaker plants. And finally, it's looked at for what basically electric bill management. People who have time of use billing or other changing electricity rates based on the time or based on demand. Energy storage can be a great way of sort of moderating your time of use billing and things like that, as well as providing backup power for homes and businesses. And those are just a few examples of sort of the use cases we're seeing for energy storage. Next slide, please. Briefly, just going to give an overview of the NYSERDA Energy Storage Program. Basically, we offer incentives and technical assistance to support the deployment of energy storage systems in two categories. So the Retail Energy Storage Program provides funding for projects, residential through commercial scale projects that are under 5 megawatts in size. And the incentives will vary based on the region and the megawatt hour block allocation, depending on where we are in funding. To date, we have allocated over 161 million, with an additional 16 million remaining for residential and commercial projects on Long Island and in Con Edison territory in Westchester County. In addition to the retail program, there's also the bulk energy storage incentive program, which is for projects larger than 5 megawatts in size. Again, those incentives will vary based on project size and the interconnection year. Funding is currently fully allocated for the bulk program based on projects in the queue. However, it is possible and maybe even likely that we'll have additional funding blocks in the bulk storage program coming in the future. Next slide, please. A brief snapshot of energy storage deployment to date in New York State. As of recently, at the end of April, we had over 115 megawatts of installed energy storage system capacity in New York State, comprising over 1,100 projects ranging from residential through utility scale. Additionally, as of the end of April, we had another 1,000 megawatts that is contracted and under development in various stages of development in the queue. And that comprises over 100 commercial and bulk projects in addition to the residential projects in the queue. Next slide, please. In the second webinar in our series, we did focus on fire safety, and I just want to give a couple of key takeaways from that webinar. A couple of things that you should know. Number one, codes and standards have evolved as energy storage system technologies have evolved and become more prevalent. And as a result, we have significant nation-leading protections built into the New York State Uniform Code as of the update in 2020. And that includes both the residential code and the fire code. So everything from residential to larger systems, there are significant protections for local governments which are available without the need for adoption at the local level outside of New York State. In addition, certain projects based on requirements in the code will have to perform what's known as large-scale fire testing to ensure installation safety. And that's going to be the information that gives the local code enforcement officials, your local permitting authorities, the confidence that they need to be able to look at a project and know that it's going to be as safe as it needs to be installed. And finally, I just want to note that the New York State Office of Fire Prevention and Control under the New York State Department of Homeland Security, NYSERDA and subject matter experts are partnering to ensure that training and critical information is available for the audiences that need that, including volunteer and career firefighters across the state. So please stay tuned for those trainings. We're looking forward to getting those up and running in the near future. The third webinar, next slide, please. The third webinar in our series focused on permitting and zoning and really was a walkthrough of the resources that NYSERDA has available for local governments on energy storage. First off, a couple key takeaways from that. The regulatory framework for permitting energy storage, if it's a battery that's paired with a large-scale renewable generator, it will be permitted at the state level under the Office of Renewable Energy Siting. However, all other projects, regardless of size, will be permitted at the local level under seeker and any local land use requirements that have been implemented through zoning. And so for that reason, I would encourage any local government official listening to consider, taking some steps to codify requirements at the local level for energy storage by, using NYSERDA's model zoning law or a model permit and inspection checklist to get your regulations on the books. And the Energy Storage Guidebook also contains all of the code references contained in the 2020 New York State Uniform Code for energy storage as a convenient reference for code enforcement officials. And that is our recap. Next slide, please. We'll spend just a couple minutes here going over an introduction to battery energy storage systems, decommissioning rather. Next slide, please. And first off, we'll just want to make sure that we're defining decommissioning. And conceptually, decommissioning is not an idea that is unique to battery energy storage systems or clean energy itself. Decommissioning activities and really the planning for decommissioning plays a key role in all power assets, not just battery energy storage, and all other major grid infrastructure as well. Everything from substations to solar farms need to be planned for when it comes to decommissioning. Now, when we talk about decommissioning, when we use that word, at a base level, we're really talking about how do you safely remove a system from active service. But decommissioning is often, more complicated than that. It's not always as simple as just flipping the off switch and calling it a day. There's a number of phases that we think about when it comes to defining decommissioning, and we'll read through some of those here. So number one, we are talking about shutting down and safely removing the system from service, bringing it offline. But you also have to disassemble, remove, and transport system components from the site. Further, you need to ensure that you are disposing, reusing, or recycling components in a safe and secure manner, and hopefully a sustainable manner as well, which we'll be learning more about tonight. And finally, site restoration and remediation is a key part of decommissioning. You want to make sure that you're not leaving the site in an unusable manner. And so as part of thinking about these phases of decommissioning, there are some key questions that need to be answered, such as under what circumstances is the system being decommissioned, and who is responsible for ensuring that there is adequate funding available to cover decommissioning? How do you ensure safety during decommissioning? And are you decommissioning a damaged or an undamaged system? And how do your protocols need to change as a result? Now, lucky for local governments across the state, going to the next slide, please. Decommissioning is built in some parts to the New York State Uniform Fire Prevention and Building Code. It provides a very adequate definition for decommissioning, which reflects what I was just talking about, how there's a staged nature to decommissioning. There's a process. We're talking about de-energizing, disassembling, prepping, and removing and disposing of these systems. So really, there's a level of protection for the decommissioning requirements that's built into the Uniform Code, even without the need for local action. Further, we do require under the code a decommissioning plan to be provided alongside the storage system permit application up front, which means that our permitting authorities should have an idea of the decommissioning procedures for these projects from the outset. This shouldn't be something that we're covering down the line. And then finally, there's also a section that actually outlines the requirements for the above referenced decommissioning plan, including both a narrative description of the activities required for decommissioning, but also a list of any protocol that will be in place for a damaged system if that's what you're removing. So again, recognizing that decommissioning might vary if the system is undamaged versus having been damaged during a fire or some other type of incident. And finally, next slide, please. We'll briefly touch on the ways in which decommissioning is reflected in NYSERDA's model law. So again, for local governments which are considering adding another layer of local protection by updating your zoning to reflect energy storage, we have some language and tools in the model law that may be useful for you, such as, again, requiring substantive requirements for decommissioning plans to be submitted with the application. We also detail requirements for ensuring the availability of funds from the developer or the project owner to cover decommissioning costs. And that is a great way of ensuring that the local government is not left footing the bill for any decommissioning. It's a very important thing that we want to make sure our local governments have implemented. Finally, or not finally, rather, second to finally, we have a section that references decommissioning under our ownership changes in the law, and that's language that's going to make sure that, if and when a project owner sells the project or a developer builds the project and then sells it to a different company, you want to make sure that that company is going to uphold all of the decommissioning timelines and activities that were mentioned in the plan from the outset. And then finally, in terms of permit timeframe and abandonment, the model law does spell out some of the circumstances which would constitute project abandonment and therefore trigger decommissioning. And so it's very important at the local level that you have that built in. And I've gone a bit over my time, so we'll go ahead and go to the next slide, please. And again, please join me in welcoming Daniel Pardo from DMV, who will be walking us through some of the key components and considerations around decommissioning energy storage systems. Daniel holds a Master's of Science in Wind Energy from the Technical University of Denmark and has 16 years of practical experience in renewable energy. As a principal project manager on DNV's owner's engineering team, Daniel provides technical advice on solar, wind, and battery energy storage solutions to utilities, system owners, and developers across North America and the Caribbean. And particularly noteworthy for tonight's content, Mr. Pardo leads the wind and solar decommissioning services for DNV in North America, and that team's got a history of over 9 gigawatts of studies done in recent years on decommissioning. He's also presented and exhibited writings at both the American and Canadian Wind Energy Associations, and previously led DNV's renewables team in Mexico for a number of years. So again, Daniel, thank you so much for being with us tonight. The floor is yours.
Thank you, Ian. And great slides and all the introduction that you provided on decommissioning and to set up the ground. Hi, everyone. So I'm going to share with you some of the, what we consider important and the type of work that we at DNV do regarding decommissioning of battery energy storage systems. Next slide, please. So we at DMV consider that having decommissioning plans and including cost estimates are an industry best practice because they allow, as Ian was explaining earlier, um, to have visibility on what will happen with the system when it reaches its end of life. So a decommissioning plan ideally will have a description of what will happen with each of the components of the system, all the infrastructure that will be um, dismantled, removed, and transported out of sight. And as Ian was saying again, that should be done in a safe manner and environmentally friendly way. So some of the key considerations that we consider should be included in a decommissioning plan or cost estimate are the five that you can see by yourselves in those slides. And I will touch on these specifically on the next slides. One of them, or first, is the project size. We'll see how can different project sizes impact on why um, there can be big differences between different projects. Now, another um, driver on how one decommissioning plan can be significantly different from another one has to do with the type of battery technology that it's used. And in this case, I'm talking specifically about the enclosure or the facility type, not the battery chemistry. Um, Now, the components of the weight, it's also going to have a big impact, especially on the cost that will be estimated in the plan. Um, what it's going to happen after those components have been disassembled? Are they going to be reused? Are they going to be recycled or maybe disposed of? And finally, what are typical requirements that we will see or we're seeing in different permits and regulations across different states in the US. Next slide, please. So, so I was saying before, um, looking at the project size, it's important because it gives an idea of what's the footprint of the project. So, and how much land will need to be restored at the end, how much resources are required for decommissioning the project. As an example, you will notice on the top figure, um, the foreground image or container on the white box. It's an ABB container of approximately 53 feet, and these containers are usually 53 times 9 times 10 feet. So one container this size can hold approximately 10 megawatts of a battery system. Now this changes depending on the technology and on the vendor, but this is, more or less for a rule of thumb, you can think of one of these containers as a 10 megawatt capacity um, instrument. Now, you'll have noticed, and probably you'll be receiving applications for larger projects. As an example, the lower left image shows the Most Landing Energy Storage Facility in California, which is a 182 megawatt facility. So by that rule of thumb, this facility will have approximately 150 containers. So the footprint and the impact on land is much bigger for the second one, obviously, not only because of the space it's using, but also because when there are several containers, these need to be connected one to another. And usually this is done by what it's called the collection system. And this collection system is in most cases underground. So disturbance of land will happen in addition to having a single small container. Um, Next slide, please. So the difference enclosure, the enclosure facility or the facility type will have an impact related to what we were describing before, or in terms of the container size, because the bigger containers are, as shown in the previous image, are more difficult to manage, to handle, and the newer technologies are leaning towards the upper right side image, also an ABB um, type of container, where the batteries are provided in blocks. So these type of blocks potentially will have a smaller impact on the site because they not necessarily need foundations. So there can be some concrete that for a bigger container will have to be constructed, whereas when using this type of modular or block arrangements, some of those foundations not necessarily have to be built. Now, this changes from project to project. The commissioning is seen at DMV, and the way we propose the entire process to be carried out, very similar to a construction process in a reverse mode. Um, these are facilities that will be, uh, before the commissioning, they will be energized, um, and they will, some of these blocks or containers will contain things such as hazardous materials. They have HVAC systems, um, and so the safety of the decommissioning process will vary depending on what type of containers are used. The installation time and the removal time will also vary, meaning this will directly impact the cost of decommissioning. There is another type of storage, or in this case, facility, which is presented in the lower image. It's called an indoor installation. Now, in this type of battery system, as you can see, there are no blocks or containers, but the battery racks are within a building. So again, these type of buildings usually require an HVAC system because the batteries need to be temperature controlled. Um, and then there's obviously a foundation, and there's a control room and additional things in that building. So the decommissioning plan will be different for a building type of battery system because of the simple fact that there's a building, and there needs to be clarity on that plan about what will happen with the building at the end of lifetime. Will it be repurposed? Will it be sold or given to the landowner? Or what is exactly going to happen? That's the type of things that need to be defined. Next slide, please. Um, so in terms of the weight components, they have another key importance in the plant because they will affect the cost of transportation. Uh, Larger containers, as shown in previous images, will require larger trucks and bigger cranes. Then the modular type of batteries will require smaller equipment, and that helps the owner save on time, but also on cost for transporting the components out of sight once they have been dismantled and removed. Now, once those components have been dismantled and removed, there will be a destination to them. Some of the components, and now we're talking about not only the batteries, but also, as I mentioned before, the balance of system, which is made of the cabling that connects the different batteries. Sometimes the balance of system may include a project collector substation, which will have some transformers. There most certainly there will be inverters as well in the project, and all of these bigger or main components for the project will be made out of metals and power electronics, and some of these can be salvaged. So having for us as consultants, when we prepare a decommissioning plan, we investigate on technical specifications and manufacturer information on the weights and quantities of different material types so that we can account for salvage on those materials. Typical materials that will help offset the cost of decommissioning are steel, aluminum, and copper, which can be found on most of the components that I mentioned before. There will be other types of materials that will not be recyclable or will not be able to use to take to a scrap yard, but they will actually have to be disposed in a safe way according to the applicable codes. These can be fluids, and these can be also power electronics. Next slide, please. So this is an image from the circular economy pathways for electrical batteries. And this one ties with what I was describing previously about the use of the batteries when they are decommissioning. When the systems are decommissioned. Sorry. So initially, or the first approach will probably be to try to give the battery a second life in a different application. Now, the battery can also be repurposed. They can also be taken to a recycling facility, as Kunal will be talking about in a few minutes. And in the last instance, the battery can be disposed. Now, the changes and evolution on disposal or end of life for batteries are quickly changing from one year to another. Currently, DNV considers two plausible scenarios when completing a decommissioning study. On scenario one, we are typically assuming that the owner of the project will bear the cost of recycling the battery. The cost we have as a reference now for a lithium-ion battery, it's something between $4,000 and $5,000 per ton. Again, this is for that specific battery chemistry. Other chemistries can have different costs, and I'll show in another slide some references to other studies which contain similar figures. Now, in a second scenario, the battery manufacturer or the cell manufacturer takes the cell for recycling at no cost. And we know, or we have used this assumption in some of our studies because we know that actually today there's at least one major manufacturer that it's offering that possibility. So this will give a range of what the cost can be under a more optimistic scenario, which would be scenario 2, and a more conservative scenario, which would be scenario 1. Next slide, please. So finally, I'll tell you what we're often seeing, permitting requirements and regulations and even landowner agreements try to address when discussing about or when addressing the decommissioning plan contents and what needs to be submitted by the developer, and at the end will be transferred as a responsibility to the project owner. Um, so some of the key points will be what's going to happen with the foundations. Anything which is underground in terms of concrete, um, can that be left or should that be removed? And if it's to be removed, what depth of removal should be applied? Um, Now, as I mentioned before, if there are buildings, can those be left? For instance, if there is an agreement with the landowner that those will be used for, or given a second life by the landowner, what will happen with the collection system if there is one? Can it be abandoned maybe if it's below a specific grade, or should it always be removed? Now, collection system, as I mentioned before, may contain some value when salvaging the copper and the aluminum in most of the cables. However, it can be expensive to remove. So there's calculation, there's an estimate that needs to be done to analyze whether it is worth or not removing the underground collection system. Um, Usually, all the type of permits, regulations, and agreements that we see require all above ground equipment and facilities to be removed. Now, there needs to be clarity about whether exceptions are permitted or not, and what are the requirements for those exceptions to be granted. For instance, submitting a copy of the landowner agreement where the owner and the landowner have agreed that they may reach an agreement to keep something like the building, as I said before. And then another typical requirement on permits and regulations refer to how often does the decommissioning study need to be updated. At DMV, we often see that, and we consider best practice that decommissioning studies are presented before the projects are actually constructed and commissioned, and that they are also updated towards the end of the lifetime, maybe 3, maybe 4 years before the end of the lifetime. However, we are seeing also that in many cases, the permits require decommissioning studies to be updated as often as 5 years, as every 5 years. Next slide, please. And so this is the slide I talked about before. It contains some very interesting documents that in case you haven't got the chance to read, I suggest you to read. They'll contain some good recommendations on what things need to be done, and what a typical decommissioning plan, what other points need to address, in addition to some of what I mentioned before. And I think with that, next slide, but I think I've reached the end of my presentation. Yeah, this is it. So thank you everyone for listening, and Ian, over to you.
Yeah, absolutely. Daniel, my sincere thank you for making the time to join us. It's really helpful to hear about, the way in which you're thinking as someone who's putting together these decommissioning plans, what are the kind of questions and issues that we should really be paying attention to. So again, thank you for your informative presentation.
Thank you for listening.
Yeah, and at this time, it's my sincere pleasure to welcome our second guest speaker for tonight's webinar, Mr. Kunal Falfer, the Chief Commercial Officer for Lifecycle, a leading North American lithium-ion battery recycling company out of Ontario, Canada. Mr. Falfer initially joined Lifecycle as an advisor before being nominated as a board member and then stepping into his current role as CCO in 2018. He brings with him nearly 15 years of professional experience, including extensive expertise in both lithium-ion battery and renewable energy at large sectors, having served as the director of product development for a residential solar company, as well as the director of business development for a lithium-ion battery manufacturer, both based out of Toronto, Canada. And as a final note, I'll just say that we're particularly glad to have you, Kunal, and we're glad to have Lifecycle represented at tonight's webinar. For those of you who don't already know, back in 2020, Lifecycle commenced operations of its first US-based recycling facility located in none other than Rochester, New York, with plans to significantly expand the company's New York operation in the coming years. Now, this marks a significant and meaningful step forward for New York's clean energy industry as we look to move towards a more sustainable supply chain for lithium-ion batteries, as well as investing in meaningful clean energy jobs across our state. So again, Kunal, thank you so much for joining us, and the floor is all yours.
Thanks, Ian, and happy to be here as a operational company in New York, and I think this dovetails well with the last presentation. So jumping right into it, Lifecycle, we're a Canadian company founded here in Toronto in 2016, and our vision's always been to provide a clean and an economic way to recycle lithium-ion batteries from all applications, including energy storage, not only here in North America, but also abroad. And that really comes in two areas of our mission. One is providing solutions where these batteries are considered liabilities or a challenge to deal with. But two, the end goal is really to bring those raw materials back into the supply chain. Like Daniel had that image from the resale center that shows all the different pathways, and I'll get into how we're doing that and bring those materials back for reuse. So just at a high level, Ian quickly mentioned it. Basically have two core technologies, which I can get into further in a little bit. But one is a spoke, which just takes in batteries, shreds them, and separates key material. That is something that we have commercialized at both Kingston and now Rochester, New York, and are building also in Phoenix. So the concept here is to have a spoke and hub setup where the initial processing is done at a spoke, and then we take some intermediate material to what we call our hub, which is really this hydrometallurgical process, simply put, a refining process to build those or create those raw materials. And that's what now we're building again in Rochester on the Eastman Business Park, where our spoke 2 also is. And here down here, you just see that we have ambitions to go beyond North America and are actively looking at that as well. So just briefly, one important aspect of this business is not just to be a commercial operation, but to do it safely, both for our employees and then also with minimal impact. So we've highlighted that achievement through our ISO certification for a Canadian location, and in the summer we'll also be certified at our US location. So, I mean, we've talked, I think, in this about a lot of about decommissioning and how the importance of having a decommissioning plan for your energy storage project and having a sustainable home to take the batteries. But I wanted to step back a little bit just at the broader sense of lithium-ion batteries. You know, where have we come from and where is it going, and why is recycling such an important topic that we see, you know, President Biden also talking about it. So in the last 10 years, you would see that, you know, the lithium-ion demand and production growth is really first driven by consumer electronics, and then, you know, the last half of last decade, emergence of some electric vehicles and also energy storage deployment have got us to where we are. But now almost on a weekly basis, you see announcements of new factories for cells. And I think, you know, a couple of weeks ago was GM and SK. Today was Ford and SK. Today was GM again, talking about new factories. And that's what's going to drive this immense growth in the next 10 years for transport and other applications for lithium-ion batteries. So obviously, as we put the batteries into the market, eventually they're going to come out of the market. And how do we deal with this tsunami of batteries and really create a sustainable process at the end of life? When we look at the market, and so taking the batteries going into the market, our team has projected out what is going to be available to us at a global level, and you really see that we're at the beginning stages of end-of-life batteries. So the dark blue here is from what we call manufacturing scrap. We recently, for example, signed a deal with GM and LG for their plant in Ohio, where we'll take the scrap from manufacturing the cells and recycle it and recover the materials. But in the near future, this is a core part of the market because we haven't hit that large scale yet of material coming out of the market, whether it's an energy storage system being decommissioned or a vehicle coming off the road. So this industry is just basically starting, and we see that there's immense growth in the next 10 years. And of course, driven a lot by the transport and the scrap sectors, but of course, energy storage and consumer electronics will continue to play a role as a piece of the market. So how are we doing this? And I'll also get into how we're doing this differently, but I mentioned the spoke side. Some of the key aspects there, we've evolved our technology and differentiate ourselves in that we can take any state of charge and also larger component sizes. So the rack-mounted energy storage modules, we shred directly in this, and they can be of any chemistry. So particularly what we're seeing in energy storage, a lot of the discussion for new projects when they're looking at decommissioning plan, and to a certain extent, the material we see already coming out of the market, everyone wants to ask us about iron phosphate batteries. So we can do any type of lithium-ion battery in this process, doesn't matter, mix and match it. And so that's why we're well prepared for the energy storage market, as a number of recyclers won't take iron phosphate due to low material value. And so the spoke produces these three products. Two we send to external recyclers, shredded copper, aluminum, or plastics. And then the third black mass contains the valuable battery materials. And that's what, as I said, was operational already. The hub, though, which we piloted and now are in the process of engineering, permitting, constructing, is where we can refine that into battery grade metals. And so when I talk about iron phosphate, the reason others don't take it is because they don't have the ability, or they're selling it to a smelter where the lithium can't be recovered. So a key part of this hub is that we've designed it specifically around processing of black mass from lithium-ion batteries, and we could produce battery grade cobalt, nickel, and lithium, which we're now qualifying with downstream vendors, but also then produce a number of byproducts that can be sold into other streams of the economy. So how do we do this? And what's maybe most important for the audience here is that it starts with really our services arm. And, it's going to depend on the vertical we're applying for or working with. But generally, one of the key services is how do we help batteries get from our customer site to us? And for that, we can help to provide packaging advice, logistics coordination, and then even have done other things like manage battery replacement campaigns for automotive groups. In that context, we do, for example, pickups from dealerships. When it comes to energy storage, though, we really extend our service to that point where we're not yet or haven't yet made any investment, is the ability to perform the entire decommissioning, and that's where we find partners. For example, we work with Renewance. There was a press release, I think, last week about it, that we partner with them where they take care of the full decommissioning, boots on the ground, separating out the parts, and our core focus is on the lithium-ion battery piece. That then goes obviously into our technology, where we have a very high recovery rate, and then goal then is to bring the products and back into the supply chain of our customers. And as this business grows and the scale grows, those could be the same customers that are providing us batteries on the front end. So I think just to highlight some of the key things that I mentioned was full molecules, fully charged. This allows us to, not have to discharge or have manual intervention on the batteries when they get to us. It's a very clean process. So though we use a submerged shredding process, there's no wastewater production. The water that's used is still contained in the products as they are sold as moist products or wet products. And we continue to evolve the technology to take bigger and bigger pieces. So the energy storage modules we can already do. As things get larger, like full EV packs, we're looking at how do we process those directly. So very briefly, this is our plant in Kingston. It was built into an existing facility. You see the conveyor there where the material goes up, shredder somewhere back there. It's a little bit hard to see. And there's a series of conveyors and other mechanisms to separate out the black mass and metal products. However, moving forward, the innovation is that how do we standardize this and help to control the quality of the production. So our Rochester facility, we actually built these modules in Kingston, shipped them down on 6 flatbeds, and then installed them in the building. So within a month of arriving on site, we were operational at the site. This is how we're going to do our next plants as we move forward in the future. Again, on the hydromet side, this is a very specialized process for this. Key is that it's low temperature operation. There have been some instances, actually, when you look at the end-to-end process, that's been hard to permit for other recyclers because they have thermal processes or high temperature process somewhere along the chain. That is not the I guess future of recycling, as it becomes harder and harder to site those facilities. And then also we see demand for customers not to have that type of a process due to harmful emissions that are generated, for example, from PFAS chemicals. Interesting, our team saw that there's also been PFAS has been in the news around makeup and the use in makeup. A lot of people know PFAS also from Teflon coatings, etc. So that comes from the binder and electrolyte being burnt off in other processes, and something that we've avoided. And also we minimize our waste through a zero liquid discharge. So again, no wastewater, but a small stream of solid waste. This is the rendering of just what it will look like. As I said, we're completing the engineering in the permitting phase and breaking ground later this year to be operational at the end of next year. Our decision also to go this route to the basic materials was made really around, we see that cathode chemistries are changing. It's better to be focused on various building blocks or key building blocks that can be used in multiple applications or types of chemistries. And that's why we've gone to the lithium nickel cobalt sulfate. There's other approaches out there, but we feel this is the best to be prepared for the future. So just very briefly, I think I mentioned some of these things, but from an environmental perspective, this is a much stronger operation, again, coming from no wastewater and no thermal treatment. We're able to take a large mix of batteries and battery applications, again, within the lithium-ion family, and we're ready to scale this for the future. And we're starting to do so right in Rochester. So I'd like to thank you for the time. I think we have some Q&A, and I'll turn it back over to the team.
Great. Thank you, Kunal. Sal, if you could pull up the few remaining slides that we have on the NYSERDA end. By the way, I'm Jen Menier from NYSERDA's Clean Energy Siting team, filling in for Ian now. He had to leave for a previous commitment, But before we get into the Q&A, I just want to remind everyone, and I know Ian teed this up in the beginning of the webinar, but I want to remind everyone about the resources that NYSERDA has, that our clean energy siting team has for everyone with respect to battery energy storage. So a reminder, on our website, and it's also available in hard copy form, we have the New York Battery Energy Storage System Guidebook for local governments. That includes a model zoning law that you're free to adopt, modify as you see fit prior to adopting. It also includes a model permit and inspection checklist for smaller systems, and a full copy of the 2020 New York State Uniform Code references as they pertain to battery energy storage. So pretty much everything you need all in one place right there. And just a shameless plug for our clean energy siting team, in addition to the resources that we have on our website that include the guidebook, we're also here as people available to work one-on-one with you, your municipal boards, local officials, and pretty much anyone who reaches out to us. We're happy to provide free technical assistance. And similar to these webinars that we're doing right now, like this one, we also offer other accredited trainings for code enforcement officials and planning and zoning board members, not just on energy storage, but solar and other topics as well. So please feel free to reach out to us anytime. It's what we're here for. And again, one-on-one, call, email, visit the website, whatever's most convenient. Okay, and if you have not gotten your questions into the chat, now would be the time to do it. I think we can take a few moments for a Q&A. So one that was in the chat, if everyone cannot see the Q&A, someone asked if the spoke just burns the batteries and does it recycle any metals? So Daniel, if you don't mind just addressing that question for everyone attending the webinar. I see that you answered it in writing.
I think that one is better for Kunal. He was the one who, Lifecycler is the one that has the spokes. I was actually, I'm sorry, I clicked on the wrong one. I was referring to slide 23, which the idea of presenting, which I think it's slide 22, it had the circular economy pathways. So the idea of this graph, yeah, thank you, Jennifer, is to show, my intention was to focus on the lower right side where, you know, after a battery has been used, then there are probably second uses that can be given to them. There's a lot of discussion in the industry about what can be done in the future, you know, when batteries degrade to a 70%, for instance, in vehicles or even in utility scale systems. There are options for those batteries to be repurposed and reused in other conditions which are less demanding. And then let's say if that option is not you know, viable, then recycling, it's probably the next step. And Kunal, you're much better positioned to talk about not only the spoke, but also maybe about the types of recycling processes that are described there. But sorry to put you on the spot. I don't know if you guys follow different processes.
Yeah, no problem. So yeah, just a high level, the spoke doesn't use any thermal process, so there's no burning, and that's part of the innovation. And there are other processes shown here, like a pyro process, where they just simply burn the batteries. I didn't go into detail there. What happens there, though, is you're burning off the electrolyte and the plastics, creating harmful emissions, but also then your lithium, your aluminum, your graphite are all non-usable afterwards. So the spoke actually shreds the battery in a submerged, in a solution. That's the proprietary piece. And then it's separating those three streams. I maybe went through that a little bit fast, but one is a plastic stream from the separator, which we work with, you know, plastic recyclers that can bring that back to its fundamental wax and oil products. Two is the shredded metals, so the copper and aluminum, which we then send for copper refining. And then three is the black mass, which we, you know, there are pathways to sell that, which we do now and have historically, but that's not our end game with the construction of the hub, which then takes that and produces the raw materials for the batteries. So I think that answers that one. I mean, Daniel, I think you mentioned to talk about the slide. I mean, resell. I like the slide that they created. A lot of people use it because it's probably one of the best pictures out there to show. But I mean, when I mentioned other processes, there's also direct recycling, or what they call cathode to cathode. and that really takes the existing cathode material and brings it back as a cathode material. Their intent is that, you're not going back into individual metals and then through that whole process again. At the same time, what we see the challenge, and when I was talking about going down to the individual metals and having that flexibility, is that the cathode materials are changing rapidly. So what's coming out of the market 5 years from now is probably not being used in new batteries. And so what is the purpose of making new cathode of that type, like a NMC type 111? They may be in a different ratio of NMC in the future, and hence that they're still trying to resolve that issue, and there's no real commercial direct recycling at the moment. On the slide, I would also just say that the cost of recycling in today's market is not that high. It's going to a cost positive for nickel cobalt based chemistries. Most of the time should be cost neutral or cost positive for the owner of the batteries.
That's great news, Kunal. That's the type of things we want to hear from companies like you.
Yeah, and with iron phosphate, it's a little bit different because there's less material value.
Great. Thank you both for all of that additional information. I have a question for Daniel. Is there any more information that you could share about manufacturer take-back programs? I think folks might be interested in hearing a little bit more about that, if you don't mind.
No, that's a great question. It's been about a year from the last time that we had a discussion with Tesla about how they were taking back their batteries. It's becoming, I think it's going to become more of a trend. Actually this week, I know it's a different subject, but in a certain way similar, one of the major solar PV modules manufacturers announced that they are also offering taking back PV modules, because the situation we are facing with PV modules, it's relatively similar in the sense of, we're deploying them at a very fast pace, and there will be a moment in time where we need to do something with them, which is not, throw them in our backyards. So I suspect this is going to become more and more common. Plus, obviously the recycling option that companies like Li-Cycle have, which it's fantastic for news for the business.
And I think this next one will probably be for Kunal, but Daniel, of course, feel free to jump in. Can you comment somehow on the current state of mining for materials for lithium-ion batteries, and perhaps to what extent recycling might make that perhaps totally unnecessary in the future, or at least less intensive? It's a concern that is brought up to our team fairly often. So any wisdom you have to share in that front would be appreciated.
I could go first, Daniel. Yeah, it doesn't really matter which industry report, BNEF, Benchmark Minerals, or whatever, but everyone's projecting for all the factories that have been announced to build lithium-ion batteries by 23, so let's say 2025 and beyond, there's going to be a cobalt, nickel, lithium shortage relative to what people are projecting they're going to build. It's a big bottleneck, so there's definitely more investment needed in new raw materials, whether that comes from recycling or mining and refining. The problem is right now we're in such an accelerated growth period of the lithium ion demand that you're not going to have, even if you built a lot more recycling plants, you don't have enough material coming out of the market to make it self-sustaining. So in the next 10 years, for sure, you need more mining to just fuel that dynamic growth and building out the recycling capacity. And then you'll start to see a bigger dent from recycling output, right? When we talk about our output with buyers of, say, nickel, 1 gigafactory or 1 mega factory uses more nickel sulfate than we can produce from one facility. But there's just, you need to produce the batteries, get them in the market, bring them back out in order to have the material to make it truly self-sustaining.
Yeah, and that actually, Kunal, I think I'm going to use it as a segue for answering the question on how many battery systems have been decommissioned. So I think probably all of the systems that have been decommissioned at some point have been because of emergency situations and not because of, end of a lifetime operation. Um, and I know of approximately four, fire incidents across, Europe and the United States in the last 2 years or so. I haven't, or we at DMV haven't worked on a system which has been decommissioned because it has reached its end of lifetime. And this is actually in line with what Kunal is saying, which is these battery systems are almost just been deployed, right? So we won't start seeing decommissioning happening before what, maybe 10 years or so, and then that's where we're going to start seeing um, what happens. And then even in that case, I would say we don't know what the landscape is going to look like in 10 years. And I'm saying this not to remove any, importance to the discussion on having the commissioning plans or so. I strongly think we should have it. But if we look at the wind industry, which is, for instance, another industry in which I often work, wind power plants, many are not being decommissioned. They are being repowered and not decommissioned. Repowering can happen in a partial way or a full way. A partial way, it's some of the turbine components are being removed and replaced with newer technology. In a full way means the entire turbine is taken away and then a new turbine is built. So in that part, there is some decommissioning work. But again, 20 years ago, we didn't know repowering was going to be so popular. Nowadays, we're seeing lots of repowering in wind. Sorry, I'm talking about a different technology, but it was just to, help frame what we don't really know exactly how the future is going to be in 10 years.
No, it's great. No need to apologize for bringing in other technologies. It all sort of goes together, and I'm sure everyone on the webinar right now is interested in everything. So appreciate it, in fact. This one, I believe, will be for Kunal. Is there a hub that is currently operational, or is it just a spoke so far?
Yeah, just in Kingston, Ontario, we have our pilot hub, but we've ran it. We learned everything we can for it, and this is our first one that we're building in Rochester to be commissioned end of next year. But there's really, we're the most advanced in terms of getting to something like this in North America. So we shouldn't see any other similar hubs yet in North America, but we will need more down the road.
And I know you answered this in the chat, but perhaps everyone's not monitoring, so I'll ask it again. Who conducts a decommissioning plan? Is it typically contracted out? Are there companies that do it?
Yeah, so we at DMV conduct that type of decommissioning plans on behalf of owners and developers. So anyone that wants to talk specifically about a plan, we're happy to, support that request.
Not that I'm trying to get you to advertise perhaps for competitors or anything, but do you think, are there other companies out there that would do it? And if so, like generally what types of companies might they be? Like how would one go about finding out who they are?
Yeah, there are other consultants that complete decommissioning plans. Frankly, I haven't seen them for battery storage. I've seen them for wind, which are pretty common. So other renewable energy consultants may potentially do battery storage. We are doing battery storage decommissioning plans for the last year or so. So it's not, it's not an old service that we provide. It's relatively new, just 1 year time.
Thank you. Last call for any technical questions. I think we've gotten through everything that's come in so far, minus one question that's more logistical, wanting to know if there are certificates for attending these sessions in the series for perhaps planning board members to get credit for their annual training. And the answer to that is yes, we can do that. Just shoot us an email at the email address that you see on the screen there on the slide, cleanenergyhelp@nyserda.ny.gov, and we're happy to pull together a certificate for you to document this. So I'm not seeing any other questions popping in? So it looks like we're going to be wrapping up right on time, if not a little bit early. But before we do that, I just want to remind everyone that there is one more webinar coming up in the series, our final one on taxation and assessments for energy storage systems, and that's on Wednesday, June 30th. And one last check on the questions. Nope, we're good. And with that, I guess we will end 3 minutes early tonight and everyone can start their evening a little bit early. And I'll reiterate Ian's sincere thanks to both Kunal and Daniel for joining us tonight. Your expertise is invaluable, and have a great night. Thank you.
Thank you.
Thank you, Jennifer, and everyone. Have a good night.